So let's go over the concept of position vector real fast. Very easy concept. You should have seen this when you learn how to graph, so most likely in Math 135. We're just going to overlap the concept of vector on top of it. So let's consider the usual coordinate system, x and y, x being positive towards the right, and y being positive up. That's the assumption that I make. Let's imagine that I want to consider 2 points. Let's say point A, coordinate of 2 and 3, so maybe somewhere over here, and another point B, was coordinate of 7 and 6. What does that mean? It means that first to position point A, we went by 2 units along the x, and then 3 units along the j, and then we put the point at this particular location. Same for B. We went 3, 4, 5, 6, 7, and then 3, 4, 5, 6. Kinda. So those are point coordinates, no problem. What we can do, and this will be very relevant in 3D, so next semester as you take statics or dynamics, you can superimpose a vector that goes between 2 points in space, in 1D, 2D, 3D, 4D, 5D, and D. That is, we may be interested in the vector that starts at A and ends at B. We're going to call this vector AB. So vector AB says that we start at A and we end at B, so the order matters. Of course, it would be very different from the vector that starts at B and goes towards A. That would be vector BA. And as you know from vector, obviously AB will be negative BA, because those two vectors have the same magnitude but opposite direction, which is reflected by the negative sign. Okay, so the question is, how are we going to represent analytically this vector AB? Not a problem. The recipe is very simple. We're just going to take the I component and the j component. For the I component, we're going to take the final x component minus the initial x component. Therefore, xb minus xa, because x relates to I. And obviously for the j, we're going to do the same technique. We'll start from the final one minus the initial one. Therefore, yb minus yb. And that's it. So it's very similar to what you learn in calculus as delta. Delta is always taking the final minus the initial, and we don't care about what's in between. So in this particular case, vector AB would be xb is 7 minus xa, which is 2, and then yb is 6 minus ya, 3. And hence our vector AB is 5i plus 3j. As usual, we can double check positive I, positive j. Therefore, vector AB goes in the first quadrant. Sure enough, it is in the first quadrant. Okay, so that's how we calculate position vector. You take the final point minus the initial point for both x and y. If you're in 3D, you can add the z component difference times the unit vector along the z-axis, which will be k. If you have a fourth dimension, you do the same thing, just keep adding them up. Very easy. Okay, so that's how we calculate position vector. So we can write a vector and call it A, we can call it F, or if we know that this vector is between 2 points and we know those 2 points, that is, we can physically measure where those 2 points are, then we can express a vector that goes from one point to the other and express it in complementation, like we just did. Whoops.